Hi, I am K. Dhanagaran. Today's class, we are going to discuss about loading in a transmission line. Here, we are going to discuss about what is loading and what are the types of the loading. First, what is loading? So, loading is nothing but adding inductance in the series of transmission line. So, which means automatically we can increase the inductance value over the transmission line. So, what is the purpose of increasing the inductance value? That is for to reducing the attenuation loss. The main enemy of the transmission line is always attenuation loss. You need to take care very well. So, in this, if you decreasing the attenuation well, you can get better communication from transmission end to the receiving end. That means there is no loss from the end side. Here we are having the equivalent circuit of the transmission line, which is RL and GC component. Here we are having distortionless condition of the transmission line, which is R by G is equal to L by C. So, but practically you need to focus about the L value should always maximum for get better communication. For that, it is very difficult to reducing the resistance value and also capacitance value and compare with the inductance. The only possible way is to increase the inductance value L is very well. For that, we are having a three types. First one is continuous loading. What is continuous loading? The name itself indicates we are going to continuously loading the iron or maybe some magnetic material over the conductors. There is a transmission line. The material is bounded around the entire length of the transmission line. So we are going to continuously wound the transmission line, which is called continuously loading. So we can increase the inductance value up to 100 millihenry per kilometer. So since we are using the length for the entire transmission line, the cost is very high. So it lines to very expensive. So automatically the permeability of the transmission line will get increased very well. The major application of this type of loading is ocean cable communication, right? Second one is patch loading. What is patch? So it is nothing but instead continuously loading over the transmission line, we are going to loading with the mean of by separation. So one portion is having a continuously loading line. Next we are having an unloaded area. Next we are having a loaded one. So loaded and we are having next unloaded. Another we are having a loaded. So we are going to separate by the two loaded and unloaded things. So when compare with the previous one, the cost is very reduced in this method. So there is no major difference between the previous one and this one with respect to the performance. So in this method you need to take care about the loading length up to 1 by 4th of the entire length. This kind of method is applicable for submarine cables only. Third, we are having lump loading. What is lump? We are going to adding a external coil over the transmission line conductor with some uniform intervals. So we need to load the external coil mainly with the same intervals. That is the main thing. So we are adding externally. That's why. Then this type of method is act as a low pass filter. What is the low pass filter? So it's only response for the low frequency of signals. When you reach high frequency, the attenuation will get very higher. So it attenuates entire signal after the cutoff the range. So for higher frequency, alpha will be very huge. The major drawback of this method is you need to design properly for this lump loading. See, if you not properly design this method, the losses will be very high. When compared with previous method, you need to design very properly. So that's a main thing. Next, we are going to compare the frequency under attenuation graph. Uh, Here you are having frequency axis and attenuation axis, right? In a unloaded cable method, so when you lead the high frequency, it has the maximum attenuation, right? It is an unloaded cable for a high frequency, lower to higher frequency, the attenuation will be very very high. Next, we are having the continuous loading. So when compared with the unloaded cable and continuous loading method, so the alpha, which is attenuation, is very get minimized. It is get very minimized. Almost 60 to 70 percentage of attenuation will be get minimized from this method. There is no cutoff frequency when compare this the operations. So next we are having lump loading. So in this case, the main difference is after some cutoff frequency value, the attenuation will get very very high. So it's like you act like a low pass filter. So after some cutoff value, automatically the attenuation will be very very high. So it is work similarly like a low pass filter. I hope you can understand this topic very well. Thank you so much.